Okay, welcome everyone, and thanks for joining the Manchester Java community today. Let me start by saying thanks to our sponsor RecWorks, who cover the meetup fees for the Manchester Java community. We really appreciate this, so thanks RecWorks for providing this sponsorship. So today we have Sergio del Amo Caballero joining us, who is a distinguished engineer at Object Computing, where he works as a developer advocate for the Micronaut and Grails frameworks, as well as the Apache Groovy programming language. He's also a core developer of the Micronaut framework since its inception. Thanks for being with us today, Sergio. If anyone has any questions during today's talk, if I could ask you to pop them into the chat area Zoom, and we'll try and get them answered as we're going along today. Okay, without further ado, I'll hand over to Sergio for his talk on the Micronaut framework.
Yeah, thanks everyone for having me. Thanks for inviting me to your Java user group. It's always cool to speak in user groups, so it's like a bit more informal. I'm going to try to share my screen and introduce you a little bit to the Micronaut framework. So hopefully you are able to see my screen, and I'm going to
yeah, all good.
Search for the chat window. So Micronaut, what is Micronaut? Micronaut is a framework on the JVM. We like to call it a foundation framework because it is not like a framework to write a typical web application, although you probably will use it to write web applications, but it's a framework that you can use to build everything from command line applications to things such as functions that you deploy to AWS Lambda. You can use it, for example, the dependency injection engine in Android applications. You can use the Micronaut HTTP client almost everywhere. And you can use to create pure messaging applications. I'm going to be showing you today an introduction talk. So the idea is to show you like create an application with you and show some concepts around what the framework has to offer for you. The home of Micronaut is micronaut.io. And in fact, everything that I'm going to talk to you, you should be able to learn from the website. I don't know if we can disable drawings or that's possible. That's probably a question for you, John. Nathan?
Yeah, I'm just looking for that option now.
So the home of Micronaut is micronaut.io. The Micronaut is a modularized framework. So if you click here in user documentation, you will see that there is a lot of documentation for different modules. Micronaut is a framework which allows you to write your applications with either Java, Kotlin, or Groovy. For both Java and Kotlin, most of the compiler work is done via annotation processors. For Groovy, it uses AST transformations. You can build your Micronaut applications using either, we like to say that Micronaut is build agnostic, so you can use either Maven or Gradle. We have plugins for doing both. You can find the link to the documentation here. You will find links to all the different modules as well here. So if you want to use any kind of support for something like, I don't know, like OpenAPI, which we will show you, I will show you like there is a module for that, or GraphQL, please check those. The easiest way to start with Micronaut is to visit Micronaut Launch. You will find here a link in the main navigation, or if you go to the homepage in Launch, a project. We have a subdomain, so the subdomain I believe is launch.micronaut.io, which will read to micronaut.io/launch. And here is similar. If you are used to a Spring Initializer, this is similar to the Spring Initializer. Essentially, is a web application which allows you to generate a Micronaut application, and we support Java versions 8, 11, and 17 in Micronaut 3, which is the current release. and this led me to talk about how old is Micronaut. So Micronaut was open source, and I am just searching my notes because I don't remember. I think it was 2018. So I think it's already. So we actually announced it in Greech 2018, and then we released, I think, the first Micronaut 1.0.0 was in, I believe, in September 2018. So it's already like. I like to say that it's already like well tested and used by many in production. So no fears around that. The framework is already like almost. We are going to be releasing Micronaut 4 this year, so it's going to be the fourth major version. So no fears around that. We are also test framework agnostic. We support JUnit 5. Spoke and CodeTest if you prefer the Kotlin cup of tea. I am going to be using today JUnit 5, although I typically like my preferred combo is Java and Spoke. But let me try to see if I am able to do this talk with JUnit 5. So let me try to do that. So I'm going to select Micro 334. We have different kinds of applications. This is related to what I was telling you before. So we have support for writing like command line application, serverless, gRPC. If you are interested after this talk in what Micronaut has to offer for Lambda, I do a training around the Lambda by the end of the month. So if you are interested on that, check resources and you will find a link to that. I'm going to be selecting Java 17 because we have support for things such as Java records. So if you are in the position to use Java 17 in your company, we recommend you to do that and start enjoying the Java 17 features. The developers of Micronaut, we are still living in the Java 8 world. So yeah, we are sorry about that. So let me write an application. Let me call this Manchester Jug. I'm going to be selecting Gradle because I am more comfortable with Gradle than with Maven. But if you are using Maven, you should be in good hands. I'm going to be downloading the zip file. I'm going to take the zip file and zip it and drag and drop to IntelliJ. IntelliJ Ultimate has great support. If you want to use, has great support for Micronaut. If you want to use any other editor such as Visual Studio Code, there is also a Micronaut plugin released by the GraalVM team. So that should work fine as well. And let me. So this downloaded a Micronaut application. I make the font hopefully big enough. If anyone needs me to make the font bigger, I can do that. So we have a main application class. Nothing fancy. It's a main with essentially runs the Micronaut application. They will start a server using Netty. We have support for different runtimes. You define those when you are using Gradle. You define those here using the runtime extension of our Gradle plugin. We have support also for servlet. So if you want to deploy Micronaut to Tomcat, you could do that. We have a servlet module. By default, the default thing is to use Netty, and that's what I am going to be using in the application. But our Micronaut server Netty is just one of the available runtimes. And we have a test as well. Micronaut test, they are really fast, and they, at least for me, they change the way that I develop applications. You will see that when you are using Micronaut, the testing pyramid that we typically say that there are a lot of unit tests and there are fewer integration tests. That pyramid for me is reversed, where the tests are so fast that we will be almost always testing using functional tests, which has the tests that allow me to sleep well at night. So what I'm going to be doing is, let's start to create an application. and we can be discussing the applications. Let me create a controller and let me show you what the controller does. So I'm going to create a controller. I typically do the Hello World example controller. So let me create a greeting controller. In Micronaut, we have an annotation called controller, just to be original to the name. And you can have like a path in the controller or don't specify anything. So I'm going to add a path here called greet. We have annotations also for the different HTTP verbs. So we have an annotation for get, we have an annotation for post, for put, for delete, for patch. I'm going to be creating a route for get. So let me do that. I'm going to be returning a string. I'm going to do the controller package private just to symbolize that the controller is actually not being instantiated by us, but by the framework. I'm going to return here, hello, Sergio. And by default, Micronaut, since it was released in 2018, it assumes that you are talking JSON by default, both producing and consuming. So if you want to produce something else, so this is not a JSON string. So I'm going to say, I am producing media type, sorry, not the Java Xprint media. I am producing text plain. I'm going to be running the application. There are many ways to run a Micronaut application. You can either, if you are using IntelliJ, just click here the play button. If you are using Gradle, we have a Gradle task originally named called run. So let me do that. And let me actually select JDK 17 runtime. Here, JDK 17. See if, let me see. Hopefully I have a JDK 17 installed. Okay. Let me add a JDK. Sorry, I just did the thing that you shouldn't do, which is update my computer just before the talk. And as you can imagine, there's some things that are going to go wrong, but fear not, we will be there. So I'm going to be using Corretto JDK 17. Hopefully. I got. Typically, it's easier to run a Micronaut application. So the app should start in a second. There you go. We have it started in half a second. If I make my font bigger and I do here cal -e, so that we see the status code localhost, I think I set greet. You see here, hello, Sergio, and you see that this is an HTTP 200 OK. So if you return by default, the response HTTP 200 code is expected, and here you see the text plain, right? Nothing fancy. Let me do something which is define a path variable, which is something that you will probably want to do in your applications. So a path variable is the thing that you will typically have as part of the path of your route. So I'm going to do here a name, and I'm going to actually, instead of returning this thing, I'm going to return name. And I'm just gonna run it again and do the curl command. Now it failed because the grid route doesn't exist anymore. So what I'm gonna do is do Sergio here, and you see here, hello Sergio. So it is easy to have like path variables we support the standard way of defining path variables is an standard, which I forgot the name, but I can point you the documentation to that. We are going to stop responding plain text. So let us respond JSON, which is probably what you will want to do in your applications. So I'm going to return a map, and that's going to be rendered to JSON by Micronaut. And I'm going to say collections Singleton map, and I'm going to say this is a message and a message. Let me run the app. And you see now that the response is JSON, and indeed the thing looks like a JSON object to me. So we are in good hands. We can also change the respond HTTP status code. So you can do here HTTP response if you want the HTTP response envelope. So imagine you want to set a header or something like that. And you can say, like, I don't know, create it if you want to respond to 201. Or we have a method that takes status. So create it will set the 201 status code. So if I just run it, you see that the application starts quite fast, and you see that now it's turning created. Let me remove the HTTP response envelope just to show you. I'm going to create a test, and I'm going to stop my application. I'm going to create a test. I'm going to use IntelliJ to generate a test. So it's telling me this is a JUnit 5 test. So we have, let me show you. Let me actually write a test without using microtest, and then I show you how to use microtest. I'm going to say greet returns hello. And I could do here embedded server. I could do application context.run embedded server .class. And when the test finishes, I could do close. And I could do here embedded server application, get application context, create bin. I could create a bin of HTTP client. Micronaut has an excellent HTTP client. And I could pass here a parameter that we will pass to the constructor of the HTTP client. And that it's going to be probably the URL of my application, so that the HTTP client that we are creating is pointing to the server that is going to be run. So this is going to be a real server with my application running there. And I'm going to Micronaut HTTP client by default will return reactive types. So it will return publishers. And typically you will not care about publishers in test. So there is a convenient blocking HTTP client, which you can obtain just by calling to blocking. So I'm going to be doing blocking HTTP client, and I have here my blocking HTTP client. And now I can do client exchange, and this is going to take a request. Micronaut request object is has a nice fluid API, so it has all the HTTP verbs as static methods. So I can do get, and I can do here, for example, URI builder off, and we set greet. I believe it was greet. And now I can say as a path parameter, use Sergio and call build. And this is going to return a URI, which is one of the thing that text. I could, for example, here pass a header if I wanted to. So this has a nice Fluid API, but I don't need anything extra. So I'm going to do exchange. Exchange has when you work with Micronaut HTTP client, you will typically use either, we have two methods that you will interact with. One is called exchange. Exchange is when you care about the HTTP response envelope. we will talk a little bit about. So I just saw the question in the chat about the bell loop. I will talk about that in a second. So you will typically work with either exchange or retrieve. I'm going to work with exchange, and I'm going to say I want the response to be bind to a string. When you work with Micron, you typically will not typically, you will not need dependencies such as Mozy or JSON, the one from Google, to bind your responses to object. Micron will do that for you. And we have either with Jackson or with a new serialization module that we have, this is going to return me now a HTTP response. And the body of the response is going to be a string. So what I want to verify in my test is that this HTTP status OK is what I get from the server. And then I can do response get body and do assert equals. And if my JSON skills don't let me down, or IntelliJ actually let me write it, this will be something like message and hello Sergio, because Sergio here is uppercase. And IntelliJ is complaining about something, which I don't know what it is. It was telling me that this is returning an optional. Okay, it's telling me that I am being brave and calling .get without its present first. Let me take the risk, since we are in a test. Let me run this. And you saw the test pass, and the test is blazing fast. So just to recap, what we did is we started the server, and we created an HTTP client pointing to the server. And we did a request, a get request. This was exactly the same request that I was doing with my curl request, just with my name with the first letter uppercase. And we verified that the response was 200, and actually that the payload was we expected to be. What the Micronaut test annotation does is essentially it will take care of creating the server for you, and it will essentially allow a dependency injection to happen in this class. Micronaut supports dependency injection in constructor injection, field injection. In a test class, you are going to have to use the field injection because the way what dependency injection will do is it will basically it will call inject this. So I'm going to have to inject the HTTP client. You can do that by doing this. This will inject the Micronaut HTTP client pointing to your server. So that's exactly the same code, and it's a bit nicer than what I wrote you, but Micronaut existed before we had Micronaut test, and we have many tests in the framework which don't use Micronaut test. So if for whatever reason you don't want to use or you cannot use Micronaut test, that's completely fine. As you saw, it's really easy to start the server or the application context without Micronaut test. The Micronaut test is just a convenience annotation. Let me show you what you can do also is you can do here client. Instead of using exchange, I could use retrieve, and I could just take here class, and I could say this is my JSON, and I could do here a string expected JSON and do this expected JSON here. And I could do here an assert equals, again, expected JSON. So when you will use retrieve and where you will use exchange. If you don't care about the checking anything in the HTTP response, you can just use retrieve. That's completely fine. Typically, you will want to work with pollos, so not just using returning maps in your constructor and using like hard-coded JSON comparisons in your tests. So let me write an object, greeting, and I can annotate this with that introspected. Introspected is an annotation that we have so that my code is able to generate meta information about this Pojo at compilation time, and that allows us to do things such as, we use that for things such as validation, for things such as being able to serialize and deserialize this class without using reflection. So I'm going to create here a private string message, and this is going to be final. Let me do this. Let me say this is going to be, can never be an empty string or a null. And I can use, I can create a constructor and a getter. And instead of, in my test, instead of returning this ugly map, I could just return my Pojo here, greeting, and do here return greeting. This is not Kotlin, so I have to call a new word. And because message is the same thing as we used in the key of the map, this is going to be serialized to exactly the same thing, and my test will still be green. And I just rerun the test, and you saw the test is really fast, and it passed. The test is starting the whole thing, the real application, no mocks of the server. This is the application running. I can use things such as newer features of Java, so I can use a record. I could say this is going to be my greeting record. And I'm going to do a string message. And I could just return my greeting record. And the test will still be green. No problem there. My code has also built-in validation. So we have a module called validation. And by default, when we create an application, we have it included here. And the HTTP validation is for validating the routes. So the validation support is there. And you will use the standard JavaX constraints annotations. So if I come here and I do a greeting and I generate a test for this, and I do greeting test, and this is a JUnit test. So I'm going to use the microtest application. I don't care about starting a server. So I'm going to say start application false, but I want the dependency injection engine to be running so that I can do, for example, inject here a validator, which is the JavaX validation validator. And I can say like, I can say blank name is not supported. And I could do here a new greeting with a blank string. And I could call validator. It has a validate, which returns a set of violations. If the set is empty, that means that the class is valid. So if the set is not empty, that means the class is not valid. So if the set is not empty, the class is not valid, which is what I am expecting. So I could say expect this to be false. And if the class is valid, I expect the set to be empty. So I expect this to be true. So validation out of the box. I will show you more about validation in a second. So really easy to validate Pojos. And this, for me, is really, I am become quite in love with using validation because this ensures that the data through your application is in a valid state. And this gives me a lot of confidence in the layers and deeper in your application so that everything works fine. Another thing that you can use is we have I showed you what we call the manual HTTP client. What I'm gonna do is I'm gonna create what we call a declarative HTTP client. This is an interface that Micronaut will implement for me. So I'm gonna create an interface. I'm gonna create an interface, an HTTP client, which is gonna point to my local server, but you could use the declarative HTTP clients, which are the beautiful HTTP clients, and pointing to an external dependency. So this is when things get interesting, is what you are not using Micronaut to test Micronaut, but when you are using Micronaut to actually consume an external API. But hopefully this makes sense. So I'm going to create an interface called greet client. This is going to be annotated with client, and I'm going to just point it to greet. This is essentially like an interface to consume my controller. Same as in the controllers, you can use the get annotation here, and I can say greet, and I can say this is going to take a path variable, a string name, and this is going to return a greeting object, for example. And you can also, like, say here, you can add a constraint validation so that you can validate the parameters before the HTTP request is executed. And I will typically like to also like the nullability annotations as well. So this interface is going to be generated at compile time by Micronaut, and I can inject it in my test as well. So I can inject here my greet client. And I can do here, I can do greet name. Sergio. This is going to be, I'm going to have to use here my path variable parameter as well. And this is going to return a greeting, right? And what I want to test is that greeting doesn't implement equals and hash code. So let me actually get greeting, get message, and test that this thing is returning hello, Sergio, I think it is. Let me run the app, the test. The test passed in blazing fast speed. And actually, let me do something which is, let me show you that this thing is running for real. So I'm going to attack. So by default, Micronaut uses Loadback. And we use Loadback in combination with SLA4J so that you have like a facade. So if in the future something better than Loadback comes, we should be able to transition easily. So I'm going to add a couple of packages here to log. One is going to be the HTTP client, and I'm going to another one is going to be the HTTP server. And I'm going to execute my test again. So just to recap, this thing is doing one HTTP request, another one, and a third one against the server. One with the manual client and another one with the declarative client. So if I just run my test, we should see 3 HTTP requests being done. So, and you see here a request, the first request, the first response, the second request, the response, and the third request, the one we did with the declarative HTTP client, and the third response. Pretty nice and pretty fast. All of these requests happens in 600 milliseconds. So starting the server and doing the 3 requests and closing the server. Typically, when you work in a Micronaut application, you want to have if you want to work with a framework, it's probably because you want to use things such as dependency injection. Micronaut has a nice dependency injection engine. And I'm going to create a service called GreetingService or use case or whatever your company likes to call your use cases. So I'm going to call here GreetingService, and I'm going to call here, this is going to generate a greeting object, and this is going to take a name. Let's say this is going to return non-null, And we can say, I don't want this to be blank. And I'm going to create an implementation of this. So I'm going to call GreetingService imp. And this is going to implement the service and the annotation that we have in Micronaut to designate a class as a singleton is singleton. So we were original as well here. So we have the @singleton annotation. We use the Jakarta singleton annotation. In previous versions of Micronaut, we were using the JavaX annotation, but the whole industry moving to the Jakarta annotations, and that's the one that you will be using. So the standard annotation for singleton. And I can do, I can move the logic that I was doing here, this instantiation of record, I can move it here. Let me just use greeting because I use greeting, but we could just use the record as well. And if you forget to add the annotation, let me write a test so that this shows you that if I come here and I do a micro test, I start the application false, and I inject a class called bin context, which is not the Java bin context, but the Micronaut one, the Micronaut bin context. Bin context has a convenience annotation and a method called contains bin. So I can do here a bin of type greeting service exists, and I can say, does my dependency injection contains a bin of type greeting service, which is the interface if you remember. And this in JUnit parlance will be assert true, because contains bin returns a Boolean. And if I run this test, the test will fail because I forgot to add the singleton annotation to my class, right? It's telling me, no, it's actually you don't contain such a bin. So if I remember to add my @singleton, this will be green. So there are a couple of options to use this service in my controller now. I could come here and use @inject and add the greeting service here, inject with field injection, and do here greet name. And if I run all my tests, the test will pass. However, I prefer using constructor injection when possible because it allows me, for example, to declare GreetingService as private final. So what we recommend you to do is to use constructor injection instead when you can, which is also supported in Micronaut. You can use field injection, you can use constructor injection, and it's the same logic. Micronaut will take care of instantiating the class for you, and it will provide you the collaborators. What else can we do? We can also, for example, leverage validation. So I showed you validation here in a test, and you probably thought like, okay, show me an example of validation being used for real. So there is this annotation called pattern in JavaX validation constraints. So this is the standard annotation, nothing Micronaut specific. And I can do things to be such narcissistic at only allowing my name and team's name. And I could come here and in my implementation just only allows those. And the idea here is when someone invokes this method in the controller, so the name comes here and someone invokes the method, this is going to throw a constraint violation exception. Micronaut is going to react to the exception and return a 400 HTTP status code because there is a handler. Yeah, I can show the Lorenzo the factories. Give me a second. So if I run the application now, you see 400 requests, and it takes me actually by default Micronaut response BND error, which, if you ask me, is an ugly format to display errors. So my code will use this thing called BND errors, which is the default in Micronaut. We use BND error. I personally like more this other error that the people call problem JSON, where there is like a specification for this, or a draft specification. And we have a module to do that. And you can also like create your own. So if for whatever reason your company uses another format, adding problem JSON is as easy as adding a dependency. So I'm going to add this dependency. You see here the error message. That is kind of an ugly JSON format. I can come here and do here add problem JSON, refresh Gradle, run the app again, and execute the request. And you see that the application now is returning application problem JSON and a nicer JSON format, even if it's not so nice in the terminal. But yeah, so two things. Micronaut respond to BND error by default for errors. You can customize it. Micronaut uses the concept of error handlers. So you can define an error handler for your exceptions. And let me show you in a test, and then I will move to some of the questions in the chat. So how can you test for, so if I do here a JUnit exception, this is going to show you how to test Micronaut HTTP client. The Micronaut HTTP client, when you receive a response that is in the range of 400s and 500s, so not found, but request, internal server error, it will throw an exception, and the exception is called HTTP client response exception, and it will essentially wrap the exception, the original cause in that exception. So the way to test that in JUnit, for example, is I think I have to import the JUnit executable, and I can do here HTTP request. I can do here, did I change here? So if I do here HTTP get grid path, so sorry, you reveal there. So I'm going to use John, which is not supported, right? And I'm going to use build, and this is going to execute the exception. So you can tell JUnit to use the assert throws, and essentially JUnit will verify that when this executable gets executed, this exception is thrown. And in the exception, you can access the HTTP status and the response. So I'm just going to verify here that the status is what we saw in the terminal, which is HTTP status bad request. But hopefully you can see that the whole, so bad request is 400, which is what the application responded here. So if I do here a test, hopefully every test should be green, and they are. All of our tests in 600 milliseconds. There is a question about factories. I typically don't mention factories in introduction talks because people typically don't create factories when they are starting, but factories are pretty simple. You can have a class called, let me see how we can use a factory in our example to make sense. Let me say, I'm going to create a prefix provider, right? Which is an interface, and this is going to provide us the prefix. And in my greeting service implementation here, I'm going to inject a final prefix provider. There is no one of these right now. So if I now run my test, the application will fail, and it will tell me that Micronaut was not able to inject a bin of type prefix provider. Let me show you that. So here it failed and it told me no bin of type prefix provider exists. So let's solve that. An easy way to do this thing will be to create just a class annotated with a singleton. I'm going to create the bin through a factory. So I can say like prefix provider factory. And typically you will use a factory in combination with things such as when you have like multiple bins of a particular type and you want to create one of, so you will use factories when you have like a more complex scenario. But essentially for factories, you annotate with that factory and then you have a method which returns a particular scope. So I can say the return type is annotated with that singleton. So the bin that is going to be created is of type singleton. I can say prefix provider, and I can say hello provider. And I can do here a prefix provider. I can even implement it here. Return. And I think this will tell me to implement the methods. And I can return hello here. Or with a lambda, hopefully. Prefix provided dot prefix. So just to recap, factories are classes annotated with a factory, and you have methods which in the return type of those methods, they are annotated with a particular scope. In my example, I used the singleton, and you will typically use this when you need to create bins which require a combination of other bins, and there are certain conditions. So we have factories in almost every module. So just if you go to the security module, you will see that we have a lot of factories for different use cases. Another thing that I wanted to show you is configuration. Configuration is quite powerful in Micronaut. We could have like a suffix configuration. And if you have experience with Spring Boot, you will feel right at home, because actually the learning curve for Spring Boot developers coming to Micronaut is really small. So I can have a configuration properties object similar to the Spring Boot one. Actually, let me rename this class. Properties, and I am going to annotate this class with configuration properties. I'm going to say grid. And I'm going to implement the suffix configuration, which is going to have a method which is going to be suffix or get suffix, just to make my life even easier. And I can have configuration that is required. So I'm going to do a string suffix, non null, not blank, and I'm going to do getter and setter. This thing is complaining because my file name was incorrectly named. So now I could inject a bin of type suffix configuration in my class. So I could come here and do private final suffix configuration, let IntelliJ do the trick and modify my constructor for me. And I could come here and do suffix configuration suffix. And we could come in configuration. So by default, Micronaut supports application.properties, application.yaml. We have in the upcoming release, we have support for TAML as well. And if you are using Groovy, you have support for application.groovy. And we have, if you are using Kotlin, even another configuration, which I forgot the name, is configuration 4K or something like that. By default, you will have application.yaml. I am going to use grid, and this is no coincidence that this matches the value that I use in my configuration prefix. And then we use kebab case. You are not going to see the difference because suffix doesn't need anything. But I could do grid suffix, and I could come here and say Manchester from Manchester Jug. And I'm going to have to modify my test. So if I run the application, my test is going to fail because I am now returning the suffix, but my test is not expecting the suffix to be returned. So it's telling me you expected hello Sergio, but the message was hello Sergio from Manchester Jug. So actually, let me fulfill the test. And that could be as easy as do this and this. And hopefully now we should be green. So configuration works is quite powerful. We have support for configuration properties, object, which has you can use Java records for configuration properties as well. We have another feature called each property, where you could have like use configuration to essentially drive the creation of beans. I have, there was another question early on the chat from Atul Kumar about, can you explain how to effectively use threading in Micronaut HTTP server? I have not used any kind of annotation. So by default, the controllers are using the netty thread pool. And the idea is that when you are using the netting runtime, you should never block the netty thread pool. I am not blocking because all my code here is not blocking, but it could be that you were like fetching the greeting message from the database, and your database operation probably will be a blocking operation. So we have a convenience annotation called at executes on, where you can specify that you want to essentially offload the execution of the method to another thread pool. And that's one way that you could do that. We have another support that we have is we have so the rule of thumb is if you are using something that is blocking, annotate your controller methods with at execute on, or you can even use the at execute on a class level. We have another method which is annotation which is to blocking or blocking, which it tells a marker annotations for methods that are blocking, and this will do the same thing. That's a weird instance of two annotations for almost doing the same thing. I typically rely more on the at execute on annotation, but I understand why people may prefer the at blocking annotation because it's kind of more agnostic and less like, seems like less netty specific, kinds of document more what your code is doing. Sorry, I got a phone call. Any questions so far apart from the two that we just covered?
Not so far.
So I didn't plan to cover much more. I'm going to do something which is I'm going to try to generate a GraalVM native image. If that's works for me, Manchester Jug. So Micronaut is a framework that doesn't use any reflection, and because of that is a match made in heaven for GraalVM native images. So GraalVM is an Oracle project, which is has many more things than native images, but probably if you are using Java, the thing that you are excited about GraalVM is native image generation. And the idea is that this allows you to generate a native image, so a native image for the operating system where you are producing the image. And this means that the application will start blazingly fast. So let me show you an example. I'm going to generate a fat jar of my application. We are using the GreetingService plugin here. We have it's the same for so I have a fat jar here of my app, which will be this one. And I could do build Java -jar, right? So let me see what Java version I am using. I'm using the Corretto JDK 17, so I could do Java -jar build libs all. And you saw that the app started in almost half a second, more or less, which is nice. And I could do here a car request -i localhost 8080 grid. Sergio. And you see the response. That's fine. Both our Maven and our Gradle plugin, they have support for building native image. Let me see if this works in my computer because I was having problems before. So I have to use GraalVM JVM. I am using this tool called SDKman, which you can find under sdkman.io, which is amazing. I recommend to everyone to use this. And this allows me to do things such as SDK list Java in my computer. And I can get a list of Java versions, and you see that there are GraalVM Java versions, so I can actually switch to use the. You see that I have it installed in my computer, so I can actually do. So I could do SDK use Java, not that one. I could use the GraalVM Java version. And if I do now Java version, I see that I am running the GraalVM JDK 17. So I could do now here a Gradle native compile. And this is going to generate a GraalVM native image of my application for my operating system, which in my case is macOS. And you're going to see that native images, they are quite fast and quite less consuming of memory. The one downside of native image is that the native image generation is a bit time consuming. Hopefully my computer will work on that while we keep the Zoom call going. While the native image generates, I'm gonna show you another cool feature, which is we have support for OpenAPI generation. For those of you who are new to OpenAPI, you may have heard the word Swagger before. So Swagger 2 became OpenAPI 3. Because they open source it, and Swagger now is a set of tools to work with OpenAPI. We have one module called OpenAPI, to be original, which allows you to generate OpenAPI. That's documentation of your application. So if GitHub loads the page, you probably cannot hear, but my fans, so the native image actually generated faster than expected. So it took 1 minute to generate the native image. So now I can run the native image by going to build native compile and the name that I used. And you saw that the app started in 22 milliseconds. Before it used like 500 milliseconds. And the car request that we used to do, you should be able to do it no problem, the same thing. And you saw that the response was really fast as well. So if you are interested in using or checking GraalVM native images, Micronaut is a perfect framework for that. In fact, we work really close with the Oracle team, the GraalVM Oracle team and the Micronaut team at Oracle. They work close, really. They're in the same department. So yeah, my opinion, if you want to work with GraalVM, Micronaut is probably the best choice to do. Let me try to generate OpenAPI documentation, and then I promise I will not talk anymore. So you will have to add a couple of things. One is an annotation processor for OpenAPI. I'm not going to specify this one because that's going to be on the Micronaut BOM. When I use the Swagger annotations, which you will typically use if you want to add some extra information, then you have to annotate. We typically annotate the application class, which essentially this is kind of what the API is, et cetera, et cetera. I can say like this is my contact, like Sergio. And I can say Manchester. So now if I run compile Java, at compilation time, this will generate under here under build classes main meta-inf Swagger. It generates this YAML file, which is the open API description of my API. And you see, if I go to, so we have support for like generating Swagger UI, but the important thing is this file. So I can actually take this file and the live demo, let me see if I can actually. You see, I can paste this thing and this automatically like shows me the API documentation. You saw that the path. So essentially Micronaut open API at compilation time, it will go through my controllers and it will generate the open API for my routes. So I define a grid route during this session and it essentially generating the path for me. You saw that I was using a greeting object as a response and the greeting object is here in my schemas. So I really like this thing and I really it's important because this essentially allows that for teams to have API documentation that is actually completely up to date with their code. So they don't have to maintain a separate set of documentation. The best documentation is the one that you don't have to write. And this is the one that is essentially generated automatically for you. So once you start using this for real, you will use Swagger annotations to essentially give a little bit more information. And those are the annotations such as operation ID. And there are a couple of another schema. There is an annotation as well. So you could use here there is like another schema annotation that you can use here from Swagger that can give you like you can provide like examples of description like this is. And if I run the compile application, this will have influence in the open API generated for you. So this is the last thing that I wanted to show you. Essentially what I show you today is my code has out of the box dependency injection, routing, validation, open API generation, really nice testing support, my code HTTP client. I didn't show you persistence. We have a great module called Microdata, which is quite similar to Spring data repositories in the way you program. I mean, Microdata is done all at compilation time. So we have the idea is that you can define your entities and you can define interfaces, and those interfaces are generated at compilation time for you. And this is similar to the pattern that you may be used to if you work with Spring data repositories or with GORM data repositories. That's exactly the same idea. There is a question in the chat. Hello, if I use GORM with many domain classes, circa 1,000 domain classes, how can I optimize the start time of application and memory usage? I think you probably will have to the start type of application and memory usage. So it depends of the version of GORM that you use. So GORM, I assume you are using GORM for Hibernate. So this is not really anything to do with Micronaut. I don't know exactly what you can do to optimize the memory usage. That's a lot of domain classes. So I don't really know what to answer you, to be honest. So you'll probably, the first thing that you'll probably have to do is try to optimize the compilation time, because I guess with 1,000 domain classes, you will have a lot of compilation time. So you'll probably have to tweak your Gradle configuration to optimize that. Are there any other questions?
I think so far. Okay, I think we've run slightly out. Oh.
What's Micronaut advantage over Quarkus? I'm not a Quarkus expert myself, so I don't really know. So it's in terms of, so Micronaut is different in the approach that we will not. So first of all, couple of things. If you are working with Quarkus, you probably lean into working a lot with Hibernate. In Micronaut, we have solutions. So we actually recommend you can work with Micronaut and Hibernate, but what we have, for me, a better persistent solution in Micronaut is using JDBC. Quarkus uses bytecode enhancement. We don't use that. We actually generate different classes. We don't touch your bytecode. So that's probably the biggest difference. Micronaut is a bit more agnostic with Quarkus, you will work with JAX-RS. In Micronaut, you typically will not work with JAX-RS. We have a JAX-RS module, but you typically will not work with that. In terms of reactive libraries, in Micronaut, you will work with RxJava 2, RxJava 3, Project Reactor. In Quarkus, I think you will typically work with Mutiny. So I guess, so I think it's a different developer experience. I think you will have to probably evaluate for yourself. They're doing great things on the Quarkus side, but yeah, I think the Micronaut is a bit more agnostic, I guess. Yeah, I hopefully you can try it for yourself and let me know if you like it. I think our documentation is a bit better. Our documentation is more organized in reference documentation than we have guides. In Micronaut, they have guides where the different documentation is spread through the guides. So that's probably what I can say about that.
I've had another couple of questions come through.
So with the GraalVM stuff, does it handle tracing agent part to generate the config for things like reflection and serialization? So you will use the trace. So you can use the GraalVM tracing agent to essentially, if you are using a third party that uses reflection, to detect that. We have a couple of annotations. One is called type hint to allow you to create this reflection configuration file, which I think is what you are asking. So in Micronaut, you will typically, let me show you an example. So I have one application that I use for demo, which is a newsletter, and that uses Thymeleaf, which Thymeleaf uses a lot of reflection. And let me see if I can show you. So I have, for example, here a class annotated with tab hint, where I provide several classes from Thymeleaf. These are classes in my application, but they are being accessed by Thymeleaf with reflection. So you have to essentially whitelist them for public access. So if I run compile Java here in this app, this is going to generate my reflection config automatically for me. Let me see if I remember what it generates there. It generates the reflection config for me. So you can provide your own, Daniel, but typically you will leverage some of the utilities that Micronaut has for you. So that essentially we have, if you tried Micronaut in Micronaut 1, which we supported GraalVM immediately, but the experience has become much nicer right now. So essentially, nowadays working with GraalVM and Micronaut is almost like you avoid the bad parts of working with GraalVM, of providing reflection configuration, etc. This is a question: which Java version is better for Micronaut projects, or what's different between Java versions, or which is better? We recommend you to use the latest LTS version that you can use. So if you can use Java 17, go for that. We support Java 8 because so we support all the features are supported in all Java versions. And we test on CI, we run our test suites against the whole matrix. So we run the test against 8, 11, and 17. There are some modules that, for example, don't support Java 8. For example, the GCP module doesn't support Java 8 because they drop support for Java 8 in the Google Cloud libraries. But almost every module supports still Java 8. But what I recommend you is will be to do to use JDK 17, if not because JDK 17 is faster. So for example, this morning we were running all our guides test suite against 11 and 17. And I think 17 ran in 99 minutes and JDK 11 ran in 120 minutes. So we saw like 30% faster there. But that's probably not Micronaut, that's just JDK, right? So my recommendation is use the latest stable that you can. And what I will try is, where do you want to deploy? Does your server or your cloud provider supports the JDK version that you want? In that case, go for that. How to specify the number of threads for blocking operation? I don't know the answer to that out of the box, Atul. We have, that should be documented in the main documentation, but I don't know the answer to that. So one thing that is important is in Micronaut, in all the modules and in the core, we have this configuration reference. This comes from real code. So this is, we generate this in compilation time. So this should be correct. So my guess is you will find somewhere here. That's probably some netty configurations. So you have here like the number of threads, these n threads. My guess, the description is not really helpful because it's empty, but I guess it's number of threads. But you will have to check the docs, I guess. There is another number of threads here. So I don't know what's the difference between these two. So by default, it seems like it depends on the number of processors of your machine.
Okay, I think that's all the questions that we've had. I think that's all we've got time for today. Thanks very much for joining the Manchester Java community today, Sergio. The video of today's talk should be up on our YouTube channel in the next few days, so keep an eye on our Twitter account for the link when that goes up. And thank you everyone for attending.
Yeah, nice to be here and thanks for inviting me.
Thank you.